Well, hello, all you grade 10 or what I call X-Men and H-Men was Holman's class, the H-Men. So, folks, today we're going to be looking at an introduction to compounds. I hope you can see we have this thing in front of us, the chemist's Bible or a periodic table. And we look here are the elements, hydrogen, lithium, sodium, etc. And you guys last week had a lesson and you were introduced, and I was very impressed. You all seem to know the names of the elements. You weren't fooled by K is potassium and so on, Ca, calcium. So you see it says there, periodic table of the elements, and then it gives the group number 1, 2, and then there's the whole lot of these in the middle. We call them the transition elements. But what I'm going to do is I'm going to take the periodic table and I'm just going to fold it over like this. So we hide most of the transition elements. And then it's going to look like this. Group 1, group 2, then there's a group 3 or 13. Let's call it Roman numerals 3, 4, 5, 6, 7, and group 8. Okay, so these are the elements that really we're interested in and that concern us. So my lesson today is just a very simple one. If we've got these here, they are in group number 1. And we're going to say that they have a valency. That means they form one bond or have one hook. So we're going to then draw H with one hook, lithium with one hook, sodium with one hook. How hard is that? Group 1, one hook. Group 2 have 2 hooks or a valency of 2. Group 3, 3 hooks or a valency of 3. Group 4, carbon, silicon, etc., germanium, 4 hooks, 4 bonds, a valency of 4. So it goes 1, 2, 3, 4. Then it goes nitrogen and phosphorus, arsenic have a valency of 3. So it starts to decline again. 3, 2, 1, 0. So these guys in group 8, helium, neon, argon, all of these guys have got no hooks. Now, what do we mean by hooks or valency? That means how many bonds will they form? So you think of them as a hook, and if they have no hooks, they can't hook to anything, and therefore they don't bond and form molecules. They just stay as atoms and elements, right? So they remain alone, and we call them the noble gases, noble because they don't join with anybody. They don't even join with themselves. Okay, so those are the noble gases. They're all gases because the particles can't stick together to form a liquid. They're just all floating around as a gas should, and a gas could. So these elements on the left of the periodic table, are they metals or non-metals? Well, lithium, sodium, potassium, rubidium, etc., cesium, francium, beryllium, magnesium, calcium, all of these on the left are metals. All those on the right are non-metals, and those on the right tend to be gases as well. Hydrogen's a little bit of an exception. It's not a metal. So just think it's the only exception, but all the metals on the left, all the non-metals on the right of the periodic table, and then we've got a few metalloids like germanium and so on that are kind of in the middle, metalloids. We don't say too much about them, but they're used in electronics. Silicon there, arsenic. So all we have to remember now for this lesson is metals on the left, non-metals on the right, and the number of bonds these metals form is 1, 2, 3. Those metals all form 3 bonds. Then we started getting our non-metals, and they form 4 bonds, carbon, silicon, and then 3, 2, 1, and 0 bonds. So on Tuesday, when I see you guys again, you're going to be given a sheet that looks like this. Balancing reactions. You're going to write your name. I'm going to write my name, which is Memo. Grade 10. Okay. And then you've got a periodic table here. Hydrogen. And then you're going to draw. It's going to have a valency or a hook of 1. Lithium, a valency or hook of 1. Sodium, a hook of 1. See what I'm doing? Now, beryllium's got 2 hooks, so you're going to draw 2 hooks. Now, if you get tired of drawing hooks, you can just draw a line. Magnesium, 2 bonds, 2 lines, but think of it as a boron now. Group 3, what has group 3 got? 1, 2, 3 hooks. 1, 2, 3. Carbon has got 4 hooks. 1, 2, 3, 4. Silicon, 1, 2, 3, 4. Frankly, we tend to draw, just this is for the fun of it, for this particular exercise, we draw the metals with their hooks to the left, and we draw the non-metals like fluorine, 1 hook to the right. These have got their hooks to the right. These have got their hooks to the left because we want to join them. Those have got no hooks. So fluorine, chlorine, and then we get to the complex ions, which act like fluorine and chlorine. Look, this is not in group 7, but it acts like it's in group 7. The hydroxide ion, manganese, potassium permanganate, the permanganate ion also has got 1 hook. So we've got some complex or compound ions here, but they also act like they've got just 1 hook or a valency of 1. Oxygen, valency of 2. Sulfur, valency of 2. The sulfate ion, a valency of 2, so that's also a complex ion. Carbonate ion also got a valency of 2. And then we've got our nitrogen, 1, 2, 3, phosphorus, 1, 2, 3. And then the phosphate ion also has a valency of 3. So you're going to be given a sheet like this, and then you're going to draw the valency of each element on this sheet. Iron acts like it's in group 2, Fe. Sometimes it's got a valency of 2, sometimes it's got a valency of 1 or 3. But let's just for now keep it as a valency of 2. I hope that that is clear. So group 1 metals, 1 hook. Group 2 metals, 2 hooks, and they to the right. Group 3 metals, 3 hooks, valency of 3 to the right. Non-metals in the non-metals in the middle. We could have drawn the hooks to the left. It might have been better. Probably would have been better. But anyway, it's got 4 hooks, 3 hooks, 2 hooks, 1 hook, and then we've got some complex ions, which you must remember their names. So we're going to give you a sheet with all the names of these complex ions, and then you must remember their names too. Okay. Now, what are we going to do? We're going to take one reactant, for example, silicon. Now, when you look, you've just drawn silicon has got a valency of 4. 1, 2, 3, 4. Oxygen has got a valency of 2. So you're going to do the same thing as we did. Lithium, hydroxide, hydrogen, chloride, beryllium, got 2 hooks, oxygen, 2 hooks. And now here, we've got to join that to that. And there's only one rule, or there may be more rules, but for now, you must join them together so that all the hooks are joined together and in the lowest number possible. So I guess that would be 2 rules. Rule number 1, make sure you don't leave any hook unhooked. And number 2, make sure you join them together in the smallest number of atoms. So look at this. It's got 1, 2, 3, 4. That's got 2. So when we form silicon oxide, Si, 1, 2, 3, 4. If we only add 1 oxygen, that's going to take care of 2 hooks. But look at that. There's another 2 left behind. There's 2 extra. So we must add another oxygen. We get there. So now your oxygen's got its required 2 hooks, and your silicon's got its required 4 hooks. So we get silicon dioxide. Silicon dioxide. Or you could just call it silicon oxide. For now, it wouldn't really matter. Now, what is its formula? So we write the 2 symbols, silicon and oxygen. Now we count. There's 1 silicon and there's 2 oxygens. We don't write a 1 if there's just 1. But if there's 2, to show there's 2, we write SiO2. Metal on the left, non-metal on the right. Subscript 2, how many atoms there are in to satisfy all the hooks. Just have a look at this one now. I hope this is making sense. You got lithium hydroxide. Look, that's got 1 hook, that's got 1 hook. So when we join it together, lithium's got 1 hook, hydroxide has got 1 hook, and there it's completely satisfied. There's no hooks unhooked. And the formula would be lithium 1, we don't write, OH 1, we don't, lithium hydroxide. Make sense? And then you've got to go and do all the rest of these. So how would hydrogen and chlorine join together? H and Cl, you see each have got one hook. You're going to know what to do. Come on, easy. What's the formula? And then what's the name? Hydrogen chloride. So normally the name's in ide. Okay, hydroxide, oxide, etc., fluoride, and so on. So we've given you some examples of names here, and you can then go on and finish and complete the rest of the sheet. So this is how we join elements to form compounds and molecules. And what is the rule? Here's the steps you go through. You first look what group it's in. Then, if it's in group 1, it's got 1 hook. Group 2, it's got 2 hooks. Group 3, it's got 3 hooks. Group 4, which silicon is, it's got 4 hooks, or a valency of 4. So you write the valency by drawing a line for each element. Then you join the 2 elements together. And if all the hooks are not full, then you've got to grab another one of those to fill all the hooks. I would like to maybe just do a difficult one. Let's just, what I would consider a difficult one. Let's just take, like, say, aluminium, which has got 3 hooks, combined with oxygen. Okay, so aluminium oxide. Now look at that. Oxygen's got 2 hooks. Do you see that if we join them, it's a bit difficult, because if we add another oxygen there, it's going to have 2 hooks. So if we join that, this is now unhooked. So what I could do is maybe add another aluminium, which has got now 3 hooks, 1, 2, 3 hooks, and a third oxygen. And then you see, finally, all the hooks are joined. And we could have a rule for this. A simple rule is to write the formula. So there's the product, aluminium oxide, Al2O3, Al2O3. Now here's a simple rule. What was the valency of the oxygen? It was 2. So you put the valency of this element there as its a subscript. What was the valency of the aluminium? It was 3. You put it there. So you put the valency of the opposite one as the subscript number of atoms of the opposite one. And then there is your formula. So that is like a little rule as well. And say this was 6 and that was 2. You always then divide by, say, 2 to get the lowest common multiple of both numbers. But in this case, you can't divide 2 and 3. There's nothing that will divide into both of them. So what is the rule then for something difficult like this? You take the valency of the oxygen, you put it by the aluminium, take the valency of the aluminium, you put it by the oxygen, and that's the formula, and that's the way that they combine. So I hope now you can combine any elements into any molecule as long as you know the valency of each element. And there you can then go and finish this worksheet.